Swagatam Kapadi Mathematics classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 8th video on the chapter Trigonometry. In this video, I am going to explain to you about the graphs of trigonometric functions. Okay, now suppose we have a function y is equal to f of x. How do we draw graph for this function? We use values for x. Corresponding to x values, we get y values. And say for example, when you substitute x1, y is equal to, you have f of x1, say y1. When you substitute x2, we get y2 is equal to f of x2. And so on like this, you will get the points x1, y1, x2, y2, x3, y3, and so on like that. Now, locating these points on a graph paper, joining them, then you will get the graph of the function y is equal to f of x. Method is same. Here also, how to get the graph of trigonometry functions. Method is same. So first of all, let us draw the graph y is equal to f of x. The graph. Now the lesson is graphs of trigonometric functions. And we know very well the function is y is equal to, the first lesson is by graph of y is equal to sin x. The graph of, and we are going to do some observations. That is our lesson. Now, I will draw the graph for y is equal to sin x. Very slowly, I will explain each and every concept. Based on that, we can draw the cos graph, tan graph, secant, and so on and so on. First of all, y is equal to sin x. What I do? I write y is equal to sin x. Now, I am going to give you the values x in terms of degrees. That is, first of all, I will take 30 degrees. Next one, 60 degrees. Next, 90 degrees. I am taking the values of x in the interval of 30 degrees. Then I will go for 120 degrees. Next, 150 degrees. Next, 180 degrees. Next one, 210 degrees. Next, 240 degrees. Next, 270 degrees. Next, 300 degrees. Next one, 330 degrees. Next, 360 degrees. So I want to confirm the graph. For the values 30 degrees side, I will include 0 also. I include 0 also. Y is equal to sin x equal to 0 also. We know very well sin 0 is 0. Sin 30 is 1 by 2. And sin 60 is root 3 by 2. And sin 90 is 1. And how we can find sin 120 value? Sin 120 is nothing but sin of 90 plus 30. Sin 90 plus 30 is cos 30. Cos 30 is equal to root 3 by 2. So this is equal to 3 by 2. Next one, sin 150. Sin 150 is equal to sin of, same thing I can go for sin of 90 plus 60 is equal to cos 60 is equal to 1 by 2. And sin 180 is equal to 0. Sin 210. Sin 210 is equal to Sine of 180 plus 30. Sine of 180 plus 30. Because of 180, I get sine ratio. Sine 30 again. And 180 plus theta lies in third quadrant. Third quadrant, my sine is negative. So we get minus sine 30 is equal to minus half. Next one. So this is minus half. Next, sine 240. Sine 240 is equal to, I can go for sine of 180 plus 60 is equal to minus sine 60 is equal to minus root 3 by 2. Next one, sine 270. Sine 270 is sine of 180 plus 90 is equal to minus sine 90 is equal to minus 1. Next one, sine 300. Sine 300 I can write 270 plus 30 I can write, or 360 minus 60 I can write. So easy way, I'll go for 270 plus 30. Sine of 270 plus 30, of course, this is minus cos 30 is equal to minus root 3 by 2. And finally, no, I have one more. Sine 330 degrees is equal to sine 330. I can write sine 330 as sine of 270 plus 60 I can write. Okay, I will go for sine of 270 plus 60, which is equal to minus cos 60 is equal to minus half. And finally, sine 360 degrees is equal to, I can write so many methods. Sine 360 minus 0 or plus 0 is equal to sine 0 equal to 0. So I could find the values of trigonometry function from sine of 0 degrees to 360 degrees. So I have the points. So I have x1 y1. x1 y1 is 0 0. x2 y2 is 30 comma half. x3 is 60 comma root 3 by 2 and so on continuously. How many points I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points I have. So I am going to draw the graph for this one. Okay. Now before going that one, I will make a nice table for this. So for the next graphs also, if you prepare a table like this, you will understand. Very nice. Okay. So very nice. Yes. I will make a table like this also, so that no confusion, no overlapping. Right. Good. Next one, take over. How? I take one rectangular system. I will take one rectangular system. I am not a drawing master, so my straight line is not in straight. Let us assume that this is x-axis, this is y-axis, 0, this is positive x-axis, and this is y, and negative y-axis. First, let us start from 0 like this. Sine 0, I am taking all these angles on x-axis, and all the output I am taking along the y-axis. First, let me indicate the values. First 0, then 30 degrees, wanted I am writing 60 degrees, 90 degrees, now sine 0 I got 0. Sine 30 is half. So somewhere I do one thing. I take this as 1 unit, and this is negative 1 unit. So sin 30 half exactly in between. So this is the graph. Sin 60 root 3 by 2. Root 3 by 2 is approximately 0.86 or 87, somewhere here, somewhere here. And sin 90 is 1. Minus. Next one we have okay. Now I noted the output from 0 to 180 degrees. Now I am going to join these points with a smooth curve. With a smooth curve. Now again I am repeating, I am going to join these points with a smooth curve. So you can ask, so why don't you join these points like a sequence? But remember, this sine function is continuous function and it is also differentiable. And we have very nice explanation about this continuity and differentiability. I will explain you in a simple manner. Continuity means there will be no gap on the graph. And differentiability means it goes very smoothly. No sudden jumps. So continuity means no break, differentiability means smooth. Since the sine graph is differentiable, therefore we must have smooth joining only, not with the segments. So my graph comes like this. This is the graph of sine between 0 to 180. Next one, 150 degrees. Next one, 180 is over. Next one, we go for 210. 210 is equal to minus half. Exactly here. This gap is more. I think I will bring it a little down. Okay. Next one, 210 is over. 240, root 3 by 2. Somewhere here. And 270, oh, minus 1. Exactly somewhere here, minus 1. Next one, again, minus root 3 by 2. Again, minus half, next to 0. So, the graph goes very smoothly like this. This is the graph of sine function. Between 0 to 360 degrees. Now, if I 0 to 360 means one rotation completed. Suppose if I take 390 degrees, what degree of transitivity? The graph completed one rotation, again entered into first quadrant, made an angle 30 degrees. That means we will get same half. That means if you take again the values from 360 to 720, 360 to 720, you will get same shape of the graph. That means the graph goes like this. This is 360 to 720. Again 720 to 180, 1080, again you get same graph. So I have come from the first between 0 to 360 degrees. Point 1. Okay, after drawing the graph, what are the observations we made? That is point 1. What is the nature of the graph in different quadrants? That is point 1. If we observe carefully, this angle 0 to 90 means first quadrant. In first quadrant, my sine graph is increasing from 0 to 1. And between 90 to 180, that means in second quadrant. In second quadrant, the graph is decreasing from 1 to 0. Next one, between 180 to 270, that means in third quadrant, it is decreasing further from 0 to minus 1. And between 270 to 360, the graph again increases from minus 1 to 0. 0 to 1, 1 to 0, 0 to minus 1, minus 1 to 0. So here, in this one, the maximum value of the graph is 1 unit height. Already we proved the sign is always like between minus 1 and plus 1. And whereas the upper limit is, this is minus 1. So, just now I told, even between 360 to 720 also, the shape of the graph is going to repeat. That means again, upper limit is minus 1, lower limit is plus 1. So, one by one, let me write. Observation. Observation. What are the observations we made? Observations. Number one. In first quadrant, sine graph increases from 0 to 1. Second graph, second quadrant, same graph decreases from 1 to 0. Next one, in third graph, in third quadrant increases further from after reaching 180, it comes down further, decreases from 0 to minus 1. Then finally, in fourth quadrant, increases from minus 1 to 0. In two quadrants it is increasing, in two quadrants decreasing. 0 first quadrant increasing, second and third decreasing, fourth quadrant again increasing. Now second observation is from the graph the sign upper limit is equal to plus 1, lower limit is equal to minus 1. Sign for all values of x belongs to real number set, minus 1 less than or equal to sin x less than or equal to 1. This is second observation. And third observation is, just now I told, the shape of the graph repeats in interval of 360 degrees. So, in which interval it is repeating? Again, I draw one rough graph here. This is 0 to 360. Again, 360 to 720. Again, 720 to 1080. So, in the interval of 360 degrees, or I can say 2 pi radians, and shape of the graph is same. So, this is called period of the graph. So, in the interval of 2 pi radians, the sine graph repeats again and again. So, the sine graph is periodic, or I can say sine function is periodic function and its period is pi to pi. So, here, third observation. Third observation is sine graph repeats in the interval of 2 pi radians. 2 pi radians. Therefore, sin is y is equal to sin x is periodic function. And the period is so this is point. So we repeat, the sine graph is continuous and very smooth. Sine always lies between -1 and +1. Third one, sine repeats in the interval of 2 pi radians. So this is periodic function and periodicity of the function is 2 pi radians. Please note down.